Steel is a testament to human ingenuity, a material that seems unyielding, almost eternal, yet is born from a process as volatile and dynamic as the world itself. To understand steel is to witness a saga that begins in the deep veins of the earth and ends in the very fabric of our daily lives. To truly appreciate the objects around us, the cars we drive, the skyscrapers that shape our skylines, the kitchen knives we use to prepare a meal, we must first journey back to where it all begins, the blast furnace. Imagine standing in a vast landscape dotted with mountains of iron ore, each rock shimmering with the potential to become something greater. These stones, forged over millions of years, are riddled with iron, the element that will become the backbone of civilization. Mining these ores is no small feat. Miners descend into the earth, navigating labyrinthine tunnels and cavernous chambers. With the roar of machinery and the thunder of controlled explosions, massive chunks of ore are freed from their ancient resting places. Conveyors and trains haul the precious cargo to the surface, where it will begin its transformation. But iron ore alone is not enough. The journey to steel requires a symphony of ingredients, each playing a vital role. The ore is crushed and mixed with limestone, nature's purifier, and coke, a form of carbon-rich coal that burns with an intensity unmatched by ordinary fuels. This carefully measured blend is loaded into the blast furnace, a towering structure that rises above the landscape like a modern-day cathedral to industry. Inside the furnace, the world changes. Temperatures climb to over 1,500 degrees Celsius, hotter than the surface of a volcano. The coke ignites, its carbon atoms bonding with the oxygen in the ore, breaking the iron free from its rocky prison. The limestone, meanwhile, binds with impurities, forming a molten slag that floats atop the heavier iron. At the bottom of the furnace, a reservoir of glowing liquid metal collects, pig iron, the first step towards steel. But pig iron is brittle, filled with carbon and impurities. It cannot yet take on the roles we demand of steel. To refine it further, it is transferred to a converter, a massive, open-topped vessel where the true magic happens. Here, pure oxygen is blasted through the molten metal at high pressure. In a spectacle of sparks and searing light, the oxygen reacts with the excess carbon, creating a tempest of chemical change. Carbon monoxide and carbon dioxide rise from the surface, while the temperature surges once more. The impurities burn away, and in these few chaotic minutes, pig iron is reborn as steel. Yet, this is not the end, but another beginning. Steel, as we use it, is not a single substance, but a family of alloys, each tailored for specific tasks. By adding elements such as chromium, vanadium, or nickel, metallurgists can create steels that resist rust, bend without breaking, or withstand crushing pressures. Stainless steel gleams in kitchens and hospitals, its chromium content forming a protective shield. High-strength steels support bridges and skyscrapers, their precise mix of metals giving them unparalleled endurance. Once the desired alloy is achieved, the molten steel is cast into molds, forming ingots, billets, or slabs. Each of these blocks, glowing with heat, weighs several tons and holds the promise of countless future forms. From here, the steel moves to rolling mills, where it is reheated and shaped by gigantic rollers. Some pieces are flattened into sheets thinner than a fingernail, perfect for car bodies and appliances. Others are stretched into beams that will support the tallest buildings, or twisted into wires strong enough to hold up suspension bridges. The shaping of steel is an art as much as a science. Every pass through the rollers alters its structure, aligning the microscopic crystals that give steel its strength. The metal is heat-treated and cooled with precision, sometimes plunged into water or oil to set its properties. At every stage, quality is tested and retested. Only steel that meets exacting standards moves forward, destined to become the infrastructure of tomorrow. But the story of steel does not end with its first use. One of its most remarkable qualities is its infinite recyclability. Nearly 40% of the steel in use today is not new, but reborn. melted down from old cars, demolished buildings, and discarded tools. This transformation happens in electric arc furnaces, where scrap steel is subjected to intense electrical currents. Lightning arcs leap between electrodes, raising temperatures high enough to melt even the most stubborn alloys. The molten steel is purified, adjusted, and cast anew, ready to embark on another lifetime of service. This cycle of creation, use, and rebirth is one of steel's greatest gifts to humanity. It means that the skeleton of a long-gone skyscraper might live on in the frame of a new train, or that the steel in a bridge may have once traveled the world as a ship's hull. Steel connects us not just through space, but through time. So the next time you cross a bridge, ride in a car, or use a simple tool, remember the journey that steel has taken. From the chaos of the blast furnace to the precise choreography of rolling mills, from the mines deep underground to the recycling plants that give old metal new life, steel is a story of transformation. It is the product of fire, force, and human ambition, a material that shapes our world while constantly being shaped anew. Steel is more than metal. It is resilience, reinvention, and the relentless drive to build a better tomorrow. Its journey is a fiery odyssey, one that mirrors our own quest to create, endure, and improve. And it all begins in the heart of fire.